Welcome back. Today we're going to be talking about solving one-step equations. This is going to be our first day. Our content objective is students will be able to solve one-step equations. Language objective is students will be able to write equations from word phrases as well as state the properties used when solving the equations. Why am I learning this? Well, it's important for science problems such as involving force, acting on an object, possibly finding the speed given distance or rate, and things like that. So notice here we have a perfectly balanced equation. We have x plus 3 on one side, 7 on the other. Notice if I subtract 3 from one side, this side will definitely be heavier, bringing down the scale. So what could I do to make sure that the scale isn't tipped to one side? How do I keep it balanced? Well, if I subtract 3 from one side, I'm going to have to subtract 3 from the other side, which would leave me with x equals 4, keeping it balanced, which means it's true. This does equal this. So algebraically in the past, some may have been taught to just go ahead and subtract 3 underneath and get your answer of x equals 4, which is okay. However, you're going to find from this point on, we typically will write up on the upper right hand corner from the number like so. We're going to subtract 3, and notice we put it towards the right corner of each number, and we still get the same answer. This is going to allow us to make less mistakes, so definitely try to adopt this method because that's what you're going to see from this point on. Okay, so we're going to go over some vocabulary. First is inverse operations. It's basically operations that undo one another. So examples might be subtraction and addition are inverse operations. So subtracting 7, adding 7 are inverse operations because they undo each other. What else? A positive 9 and a negative 9 are inverses because they, again, undo each other. Some more inverse operations that undo each other would be multiplication and division. Those are inverse operations. So an example might be multiplying by 3 and then dividing by 3. It undoes itself. Or divide by 11 and then multiply by 11. Again, it undoes itself, so that's considered an inverse operation. So there are different types of equalities. There's the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. Basically, what all of these are is if you add to one side, you add to the other side to keep it equal, you're using addition property of equality. Whatever you subtract to one side, you subtract to the other, that's subtraction property of equality, etc. Basically, it's when you do the same to both sides to make sure they remain equal, hence the name property of equality. Okay, so there are a few rules for transforming equations. Number 1, your main goal is to make sure you get the variable onto one side by itself. Okay, basically you're going to hear me say you want to isolate your variable because inevitably you want it to be x equals, y equals, j equals, whatever it may be. Number 2, always perform the same operation to both sides of the equations because we need to make sure we keep it balanced. Hence the property that we saw earlier, addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. We do those things to make sure they remain equal on both sides. Number 3, to undo an operation, perform its inverse operation to both sides. So, quick reminder, addition and subtraction are inverses. They undo one another. And of course, multiplication and division are inverses because once again, they undo one another. So with that said, let's go ahead and solve number 1. Some of you are going to try to solve this in your head, which is great, but I really need you to practice showing your steps because right now it's just one step, but it's going to evolve into 2 steps, multi-step, and even in 8th grade it's going to get more complicated. So you definitely want to practice showing your work and doing it correctly. So the very first step is you want to isolate x. That is your goal. So we're going to be using the additive inverse property. What is that? I basically want to create a 0. Why? Because like I said, we want to get x by itself. So I need to make this become a 0. How do I do that? Well, what's the inverse of adding 31? It's going to be to subtract 31 from both sides. So at this point, you'll see a positive 31, negative 31. Those are additive inverses. This will create a 0. leaving me with x equals this. So this is where you're going to want to ask yourself, do you have more negatives or do you have more positives? Here, looking, hopefully you see there's more negatives. How many more negatives are there than positives? If you need to, do some side work and figure out how many more negatives there are than positives, and hopefully your answer is a negative 21. Now, some of you are going to think that you're done, but I'm going to give you another step. I want you to check your work and make sure that your answer is correct. How do we check our work? Well, we're going to go ahead and start with the original expression, or equation, I should say, but instead of putting an x, I'm just going to put parentheses, and I'll explain why I do that. So instead of an x, I'm going to put parentheses. I'm going to go ahead and put plus 31 equals 10. Now notice x was replaced with parentheses. Why? Because I'm going to go ahead and now plug in the value that I got, which is a negative 21. So let's go ahead and plug that in. What is negative 21 plus 31? There's definitely more positives, 10 more positives to be exact. Oh look, 10 equals 10. My answer does work. So this is me checking to make sure that the answer is true. So my final answer is going to be x equals negative 21. Okay, so let's try some more. Oh, real quick, I should mention, we did use the subtraction property of equality. Why was it the subtraction property of equality? Because we subtracted 31 from both sides to keep it equal on both sides of the equation. So keep that in mind. Okay, let's try number 2. Number 2 is y minus 8 equals negative 26. Once again, some of you can do this in your head, but I don't want you to. I want you to show your work to prepare you for 2 steps and multi-steps and any more complicated equations from then. So very first thing we want to do is we want to use the additive inverse property. Why? Because we want to create a 0. Again, why do I want to do that? I want to isolate y, so I need to make this a 0. So here, what is the inverse of subtracting 8? I'm going to say to add 8 to both sides, leaving me with y equals, notice I crossed that out. I'm able to do that because a negative 8 plus 8 is just 0. Now here, you're going to ask yourself, are there more negatives? Are there more positives? I'm going to definitely say there are more negatives. Now, how many more negatives are there than positives? I'm going to say, let's see, I'm going to do some side work. There are 26 negatives and 8 positives, and you see how many more negatives than there are positives, so I'm going to simply subtract, leaving me with 18. So I'm going to go ahead and say negative 18. Now, some of you, again, are going to want to just say that is my answer, but I want you to practice checking your work. So here, to check our work, we're just going to go ahead and, instead of putting a y, I'm going to put a set of parentheses. Minus 8 equals negative 26. Now I'm going to go ahead and plug in my value for y, which is negative 18. Now here, go ahead and add the opposite. I can see that there's 26 negatives, and that does equal negative 26. So I'm confident that my answer is indeed y equals negative 18. So again, please make sure you check your work, especially on a quiz or a test. It's going to be very helpful to know how to check your work because you are guaranteeing yourself that you have the correct answer. So I'm going to say the solution is y equals negative 18. Now, remember that we did use the addition property of equality. Why? Because I added 8 to both sides. So of course we're using the addition property of equality. So now, number 3. Number 3 looks a little different, okay? Here, I'm not going to be using the additive inverse property. I'm actually going to basically look at how can I isolate n? How do I get that by itself? So one thing you have to be very careful about is understand, what does negative 9n mean? Well, it technically means negative 9 times n. So I want to utilize the inverse property, which means the opposite. Okay, what does it undo? So here, if it's negative 9 times n, I want to do the inverse of multiplication, which is going to be division. So instead of multiplying by negative 9, I'm going to divide both sides by a negative 9. Notice here, negative 9 divided by negative 9 will become a 1. That's exactly what I want. Why? Because what's 1 times n? It's just n. So notice here, I didn't want to make it a 0. I actually wanted to make it a 1. So now at this point, I'm just going to go ahead and say a negative divided by negative is a positive, so they kind of cancel each other out. And I'm just left with 70 over 90. So at this point, we have been allowing you to leave your answers improper, so that's it. You're done. But like I said from previous problems, we do want to check our work. So let's check it out. We have a negative 70 equals negative 9 times parentheses. Now, what should I put in the parentheses? Well, n is 70 over 9, so I'm going to go ahead and plug that in. And let's see what we get. So I'm going to do some side work here. We have negative 70 equals, a negative times a positive is a negative. Now I am going to go off to the side and multiply a 9 over 1 times 70 over 9. These do cross cancel, leaving you with 70 over 1, which is just 70. So does this check out? Yes, so I am confident that my answer is, the solution is 70 over 9. So let's think, what property of equality did we use in this problem? Well, since we divided both sides by negative 9, we technically utilized the division property of equality, because we divided both sides by 9. Okay, so for number 4, so here we are actually going to be utilizing the multiplicative inverse property. Why? Because we're trying to make a 1. So notice the difference. When we use the additive inverse property, we were trying to make zeros. But when we're using the multiplicative inverse property, we're trying to make a value of 1. And I'll explain in a moment why we do that. So here, this technically means m divided by negative 5. So I am concentrating on this side because I want to isolate m. So if I'm dividing by negative 5, if I want to do the inverse of that, I'm going to do the opposite of division, which is going to be multiplication. So I'm going to go ahead and times it by a negative 5. I'm going to go ahead and times this by a negative 5. It helps maybe do that, whichever one works for you. So here, notice what happens. A negative 5 and a negative 5 over 1, you can kind of count them as they cross cancel, leaving you with just m, which is exactly what I want. Now if I made 0, 0 times m would be 0, and that's not what I want. So you need to be careful and make sure you're creating what number you want, whether it's a 1 or a 0. So here, you're just going to do 14 times negative 5. A positive times a negative is a negative. I'm going to do some side work and check that out. 14 times 5 is 20. 1 times 5 is 5 plus 2 is 70. So my answer is negative 70. But once again, before you claim that this is your final answer, it's going to be imperative that you check your work. So here we go. We're going to do 14 equals a number for m, so putting parentheses for that, dividing by a negative 5. So here we're going to go ahead and plug in our value for m, which is a negative 70. Notice the negatives cancel each other out. What is 70 divided, whoops, that's not the right number. What is 70 divided by 5? It goes in once with the remainder of 2. Bring down that 0. It does go in evenly 4 times. So your answer is 14 equals 14. This is true, so I'm confident that my answer is negative 70. So I'm going to say the solution is m equals negative 70. So here, what property did we use? Well, we multiplied both sides by negative 5. So I'm going to go ahead and say that we use the multiplication property of equality. Okay, so at this point, what I'd like you to do is go ahead and pause the video and try number 5 by yourself. Okay, so let's see what we did here. So here, hopefully you understand this means 4 times x. So if I'm trying to isolate x, I need to get rid of this 4. So what's the opposite, or aka inverse of multiplying by 4? Well, it's going to be to divide by 4. Notice when I do that, 4 divided by 4 becomes a 1. What's 1 times x? It's just x. I've successfully isolated x, which is just what I wanted. Now notice here, a negative divided by a positive is still going to be negative, and you'll even notice there's no negatives that cancel each other out. Now before I write 18 over 4, well, I'm going to go ahead and write 18 over 4. I hope you understand this is not yet reduced. Both of these numbers are even, so we could divide by a 2. So I'm going to go ahead and say x equals a negative 9 over 2. But once again, before I claim that this is my final answer, I want to check my work. So we're going to go ahead and do 4 times the value for x, putting parentheses there, equals negative 18. So now I'm going to go ahead and plug in my value for x, which is right here. I'm going to plug that in, which is a negative 9 over 2. So we're going to have to basically multiply these two numbers together. I'm going to need some side work. I'm running out of space. I'm going to go ahead and do it right here. 4 over 1 times negative 9 over 2. Positive times a negative is a negative. So here we can cross reduce by 2, leaving me with, let's see, a negative 18. So we have negative 18 equals negative 18. Is this true? Yes. So I'm confident that my answer is x equals negative 9/2. So I'm going to say the solution is x equals negative 9/2. Now, remember we're expected to state the property that we used. Well, we divided both sides by 4. So I'm going to go ahead and say that we use the division property of equality since we divided both sides by a 4. So hopefully you got that one right. So with that said, now I want you to go ahead and try number 6 by yourself. Okay, so for number 6, we're trying to isolate D. So I need to get rid of this minus 22. So I'm going to utilize the additive inverse property. So basically, I want to create a 0. So how do I create a 0? Well, if this is subtracting 22, I want to do the inverse, which would be to add 22 to both sides. So that's going to be a 0 because negative 22 plus 22 is 0. This is exactly what I wanted. Now that's going to leave me with here, let's do some side work real quick. No point in getting it wrong because I'm trying to do too much in my head. So that's going to be 37 equals D. Now, once again, before you claim that this is your final answer, we want to check our work. So we're going to go ahead and put 15 equals, instead of a D, I'm going to put a set of parentheses, minus 22. Now what goes inside the parentheses? My value of D, which is 37. So here, 15 equals, what is 37 minus 22? Let's check that out. That's going to be 15. So is this true? Yes. So I can confidently say my answer is 37 equals D. So I would say the solution is 37 equals D. Now, to answer the next question, which actually they didn't ask me to do, but if they ask me to state the property, since I added 22 to both sides, that is the addition property of equality. Okay. Number 7. Go ahead and pause the video and try this one by yourself. So for number 7, you do want to isolate x. So you need to get rid of this divided by 3. So notice I did say x divided by 3. So why did I read it like that? Because I need to know what the opposite, aka the inverse of dividing by 3 is, which is going to be to multiply by 3. So I'm going to go ahead and multiply by 3. I'm going to go ahead and put it over 1. If I'm multiplying the left side by 3, I'm going to also multiply this by 3. Notice here the 3's cross cancel, leaving me with just x equals a negative 12. So before I claim this is my final answer, I do want to check my work, so let's check it out. We're going to go ahead and put x as a parentheses, divided by 3 is supposed to equal negative 4. So here for x, I'm going to go ahead and plug in my negative 12. Negative 12 divided by 3 is a negative 4. Does that equal negative 4? Yes, it checks out. So I'm going to go ahead and say my solution is x equals negative 12. Now, they did ask me to state the property. Since we multiplied both sides by a 3, I did apply the multiplication property of equality. Okay, so there you have it. So now let's go ahead and try number 8 by ourselves. So the first thing you want to do is isolate your x value. So what you're going to have to do is get rid of this minus 18 by adding 18 to both sides. That's going to cancel out because a negative 18 plus 18 is 0. Now I'm left with just x equals a, let's see, are there more positives or more negatives? Definitely more positives. How many more positives? Well, let's see. There's 18 positives and 5 negatives. So how many more positives than there are negatives? I would say 13. But as always, we can't claim this is our answer until we've checked it. So let's go ahead and check our work. We have a negative 18 plus a value for x equals negative 5. I can go ahead and plug this value in for x. Let's see here, negative 18 plus 13. I'm going to say there's more negatives. How many more negatives are there than positives? I would say 5. Is this a true statement? The answer is yes. So I'm very confident that the solution is x equals 13. Now I know it isn't stated in here, but let's go ahead and practice. If we were asked to state the property used, what would it be? Well, since we added 18 to both sides, I would say that we apply the additive inverse property, or you can say the addition property of equality, since we added 18 to both sides. Let's go ahead and pause the video and try number 9 by yourself. Okay, so for number 9, it's so important that you understand this means 7 times y. So in order to do the inverse, we're going to have to do the opposite of multiplication, which is dividing both sides by 7. So notice here we're left with y equals a negative divided by a positive is a negative. Well, what is 91 divided by 7? I'm going to do some side work. This goes in once with a remainder of 2. Bring down that 1. That goes in 3 times evenly. So I'm going to say my answer is y equals negative 13. But, as always, before we claim that that's our final answer, let's check our work. We have 7 times a value is supposed to equal negative 91. So we're going to go ahead and plug in our negative 13. Let's see if this is true. A positive times a negative is a negative. What is 13 times 7? It is a 91, so negative 91. Does that equal negative 91? The answer is yes, so I'm confident that my answer is, the solution is y equals negative 13. What property did we use? We used the division property of equality since we divided both sides by 7. We did utilize the multiplicative inverse. How? Because we were dividing both sides by a 7 to make a 1. So now let's go ahead and do number 10 together. So since we're trying to isolate w, I want to get rid of this plus 17 by subtracting 17 to both sides. That's utilizing the inverse operation. So we're going to be left with a 0 here, plus positive 17 minus 17 is 0. So now we're left with w equals, here there are more negatives than anything. In fact, there are 21 negatives and 0 positives. So w is just negative 21. But as always, let's check our work. W plus 17 equals negative 4. I'm going to go ahead and plug in my value for w, which is negative 21. Here I'm going to say there's more negatives than positives, 4 to be exact. Since this is true, I can confidently say that the solution is negative 21. Because I subtracted 17 to both sides, I did utilize the subtraction property of equality. So for number 11, same idea. Let's go ahead and do this one together. I'm trying to isolate m. This means m divided by negative 5. So the inverse of dividing by negative 5 would be to multiply by negative 5 to both sides. So here you're going to cross cancel, leaving us with just m over 1, which is m. Here a negative times negative is a positive. We're going to do some side work. 12.5 times 5, that's 25, carry the 2. 2 times 5 is 10, plus 2 is 12, carry the 1. 1 times 5 is 5, plus 1 is 6, move the decimal over 1 spot. So we're going to go ahead and claim that m equals 62.5. But, as always, let's check our work. We're going to put a value for m, divide that by a negative 5 to check and see if it equals negative 12.5. Let's go ahead and plug this in for m, which is 62.5. Let's see, a positive divided by negative is a negative. I'm going to go ahead and check to see if this works. We're going to do 62.5 divided by a 5. Bringing up that decimal, 5 goes into 6 once. 5 goes into 12 2 times. 5 goes into 25 5 times, so my answer is negative 12.5. Does that equal negative 12.5? The answer is yes. So I'm going to go ahead and say that the solution is m equals 62 and a half. And I'm confident because I did check my work. A lot of you guys might be tempted to just skip that step, but please understand doing all the work, especially when we get to two steps and multi-steps, we want to make sure our answer is correct. And especially on a quiz or test, it's nice to have that advantage of checking our work and knowing for a fact it is right or wrong. Okay, so let's try number 12 together. We're isolating n. We do that by adding 9 to both sides because that's the opposite of adding a negative 9. So now we're going to be left with n equals 30. Are we done? Nope, we need to check our work. So here, n plus a negative 9 equals 21. So n is 30, so we're plugging that in. 30 plus negative 9, there are more positives. 21 to be exact. This is true. So I'm going to go ahead and say the solution is n equals 30. And here, what property did I use? I added 9 to both sides, so I did utilize the addition property of equality. Okay, now we've come towards the end of the road. What we want to do here is write a word phrase as an equation and then just basically solve it. So here it says negative 18, so let's write that, negative 18 equals x minus 9. Okay, that was pretty easy. We just translated some words into an equation. Now I want to isolate x, so I'm going to get rid of this minus 9 by adding 9 to both sides. Here, I'm going to go ahead and say x equals, there are more negatives. How many more negatives are there? 9. So I'm going to go ahead and say the solution is x equals negative 9. Now, is it okay to also say negative 9 equals x? Absolutely. They mean the same exact thing. Okay, now let's take a look at number 14. Go ahead and pause the video and try this one by yourself. Number 14, we're going to first translate it to a number b plus a negative 3 is 15. So notice I put parentheses to make sure we separate the two signs. So now we're just going to solve. I want to isolate b, so I need to get rid of this plus negative 3. So what's the opposite or inverse of adding negative 3? Just basically add 3 to both sides. So negative 3 plus 3 is 0, leaving you with b equals 18. So I'm going to say the solution is b equals 18. Now, one thing that I did not do that you should be practicing is plugging it back in to check if it actually works. So let me do that real quick. So here, let's go ahead and plug in our negative 9 for x. We have negative 18 equals parentheses minus 9. We're going to go ahead and put a negative 9 there. If we add the opposite, negative 18 does equal negative 18. This checks out. Here, we're going to do parentheses for b plus a negative 3 equals 15. What do I put in for b? I put an 18 here. Are there more negatives or positives? There's more positives. How many more positives? 15. So does 15 equal 15? Yes. So once again, please check your work. It is imperative that we practice now so that when we go further down the road, we are going to make sure we have right answers before submitting them. So guess what? It is the end of our lesson. Thank you so much for tuning in. And as always, until next time, bye.